Hello students, today we are going to be doing our pH and buffers lab. So let's go ahead and start. Okay, so in part A of this experiment, we're going to be preparing a natural indicator out of cabbage juice. I've already gone ahead, cut up the cabbage and boiled it and brought it back down to room temperature. In doing this, I've extracted the pigment out of the cabbage leaves, and you can see how dark purple that water has become. I've also gone ahead and aliquoted different pH solutions into several test tubes numbering pH 1 through 14. We will not be doing pH 0 in this lab today. So we're going to go ahead and add about 40 drops of our cabbage indicator, or approximately 2 milliliters, to each of our pH test tubes, and we'll be checking to see what color the solutions become. I'm going to add 2 milliliters of cabbage juice to pH 1. Here's our pH 1 and the color. Next is pH 2. pH 2. Now I'll add the cabbage juice to pH 3. There's our pH 3 solution. Now I'll add the cabbage juice to pH 4. Here's our pH 4 solution. On to our pH 5 solution. pH 5 solution with cabbage juice. Next is pH 6. There's our pH 6 solution, the cabbage juice indicator. We'll move on to pH 7. And here we have pH 7. Move on to our pH 8 solution. Our pH 8. We'll move on to pH 9 solution. Our pH 9 solution. And our pH 10 solution. There's our pH 10, the cabbage juice indicator. Our pH 11 solution. And pH 11 solution with the cabbage juice indicator. On to pH 12. Here's our pH 12 solution. Now we'll do our pH 13 solution. Here's our pH 13 solution with cabbage juice indicator. And finally, we'll do our pH 14 solution. And here's our pH 14 solution with the cabbage juice indicator. Now, I'm going to hold all of these up together. You see all these at once. So here's our pH 1 through 14 solutions with our natural cabbage juice indicator. Now that we've prepared our natural cabbage juice indicator solutions, we will then go on to use these as our reference standards to check the pHs of common household substances. So let me go ahead and prepare that next part of the experiment. Okay, class, we are now going to use our cabbage juice indicator references to test several household substances. So we're going to start with 10% baking soda in solution. We're going to add our cabbage juice indicator. Mix. And then we will compare to our standard reference solutions to see what pH the 10% baking soda is. Okay. The next household solution we'll be testing is drain cleaner. We'll add our cabbage juice indicator. We have our drain cleaner. And we compare to our cabbage indicator references. The third household substance we'll be testing is bleach. So our bleach here with the cabbage juice indicator added. Once again, compare to our references. Now we'll be testing tap water. We added our cabbage juice indicator to the tap water. And once again, compare to your cabbage juice references. Okay, the fifth household substance we'll be testing is soda. Here's our soda with the cabbage juice indicator. Compare to our references. Now we'll be testing liquid dish soap. Here's our liquid dish soap. The color we have here. Let's compare. All right, let's move on. Now we're going to test DI water, deionized water. Here's our deionized water. Compare to our references again. Now we'll test lemon juice. Here we have our lemon juice with the cabbage juice indicator. Compare to our references here. All right, the next household solution we'll be testing is vinegar. We have our vinegar. All right, compare our vinegar to our standard references. All right, the final solution we'll be testing is household ammonia. We've added our cabbage juice indicator. And here's our household ammonia. Let's compare to our standard cabbage juice indicator references. Okay, now that we've checked our household solutions with the cabbage juice indicator, we're going to go ahead and use a pH meter and see what the pH value of each of these solutions is using a pH meter. Every time we move between solutions with the pH meter, we need to rinse it with deionized water. Okay. Let's start with our baking soda solution. There's our baking soda solution. And our pH reading from the pH meter. Okay, let's rinse. Now we'll move on to our drain cleaner solution. So here's our drain cleaner and our pH meter reading. Let's rinse. Now we'll move on to our bleach solution. So here's our bleach solution and our pH meter reading. We'll rinse our pH probe. And we'll move on to our tap water. Okay, so we have our tap water solution. And our pH. Okay, we'll rinse our probe. We'll move on to the soda solution. So here's our soda. And our pH meter reading. Let's rinse. Now we'll do liquid dish soap. Okay, here's our liquid dish soap. And our pH meter reading. Rinse our pH probe. And we'll move on to our deionized water. Now here's our deionized water. And our pH reading, or our pH meter. Now the pH meter does not read deionized water very well because there's no ions in the water. And we use that, the pH probe uses that to actually measure the pH of a solution. Okay, we rinsed our pH probe. We're going to move on to lemon juice now. Okay, so we have our lemon juice here. And here's our pH reading. Rinse our pH probe. And we'll measure our vinegar. So we have our vinegar. And our pH. Rinse our pH probe again, and we'll move on to our last solution, which is our household ammonia. We have our household ammonia solution and our pH. We'll rinse our pH probe one more time. And return it to its storage buffer. Okay, for the final part of this experiment, we're going to be looking at the effects of buffers on pH. In order to do this, we're first going to aliquot out 5 mils of deionized water, 5 milliliters of deionized water into 2 test tubes. And the second test tube. Okay. So we've aliquoted deionized water into 2 test tubes. We're now going to aliquot out 5 milliliters of pH 7 buffer solution. So this is a buffer. The deionized water is not buffered. So we're going to aliquot out 5 milliliters of this into 2 test tubes, the pH 7 buffer. And our second test tube. Okay. So with our first set of test tubes, we have one test tube that has 5 milliliters of deionized water, and we have another test tube that has 5 milliliters of pH 7 buffer. To these 2 test tubes, we're going to be adding 5 drops of 0.1 molar hydrochloric acid. We're first going to measure the pH of our deionized water solution using litmus paper. And we're also going to measure the pH of our pH 7 buffer solution using the same litmus paper. So here's the pH of our deionized water. Now let's check the pH of our pH 7 buffer. Here's the pH of our pH 7 buffer. Okay, now let's add the 5 drops of 0.1 molar hydrochloric acid. So again, we have the 0.1 molar hydrochloric acid. We'll add 5 drops to our deionized water. And we'll add 5 drops to our pH 7 buffer. We'll mix these solutions. Okay, so we're going to start with our deionized water plus hydrochloric acid. And we're going to use the litmus paper to check the pH of the solution. See how it has changed after the addition of the hydrochloric acid. So after the addition of the hydrochloric acid, this is now the pH of our deionized water plus the hydrochloric acid. Now let's check the pH of our pH 7 buffer with hydrochloric acid. So here's our pH 7 buffer, which we added the hydrochloric acid to. And here's the pH of our pH 7 buffer plus the hydrochloric acid. The same amount of hydrochloric acid that we added to the deionized water. Okay, we are now going to add 5 drops of 0.1 molar sodium hydroxide. So we have our 0.1 molar sodium hydroxide. We will be adding 5 drops of this to our other test tube with deionized water. Five drops. And we'll also be adding 5 drops of this to our other test tube of pH 7 buffer. We'll mix. And we will check the pH of these solutions with the addition of sodium hydroxide. Now recall that we already checked the pH of just the deionized water by itself and just the pH 7 buffer by itself before we did the addition of the hydrochloric acid in the other test tubes. Okay, so here's the pH of the deionized water plus 5 drops of 0.1 molar sodium hydroxide. And finally, we will check the pH of the pH 7 buffer plus 5 drops of 0.1 molar sodium hydroxide. So our pH 7 buffer plus sodium hydroxide. And this is the pH of the pH 7 buffer plus 5 drops of 0.1 molar sodium hydroxide. All right, that concludes our pH and buffers laboratory. Thank you.